Guys, so today we're gonna go ahead and we're gonna do adding and subtracting rational expressions. Now, one of the big things about this whole assignment is that you need to know how to add and subtract fractions. Basically, that's all we're gonna be doing. Now, whenever you have a fraction like this, I'm gonna do an easy one, and then we're gonna go over the actual assignment. Whenever you have a fraction and you have, let's say, four on the bottom, we have 7 and 3 on the top. What you're gonna have to do is, number one rule, whenever you're adding and subtracting fractions, you need to have the same denominator. If you do, it's gonna be very easy. You're gonna keep that denominator and you're gonna put it on the bottom. Now, what you're gonna do to the top is that you're gonna combine like terms. So right here I have a plus, so it's gonna be 7 plus 3 on the top. Now, I didn't do anything on the bottom because we have the same denominator. Once you have the same denominator, you can combine everything into one big fraction. Once we're done with that, we just go ahead and combine like terms on the top, which is a 7 and a 3. So in this case, this would give me 10 over 4. And that would be it. Well, we can simplify, right? We can simplify by dividing everything by 2. So that would give me my final answer. But that's the same concept that we're going to go ahead and start doing whenever it comes to this type of problems. All right, let's go with number 1. I'm probably going to do 2 of each. That way you guys can see at least 2 of them being done. Now, this is my problem. It looks a lot harder than the one that we just did, but look at the bottom. We have the same denominator. Go ahead and highlight this a little better. Yeah, those 2 are my denominators, and they're the same. So if I have the same denominator, what do you think we're going to have to do? We're just going to have to rewrite it as a bigger fraction. So on the bottom, we're going to have 24x. And then on the top, we're just going to combine like terms. So it's going to be what? 3x minus 6 plus 3x plus 6. Now, you got to be very careful with what sign you have in there. Mainly because if I had a negative, then I would have to change this one and this one. I would have to change both the signs. But in this case, we don't have to because we have a plus, so we just have to combine it just like we usually do. So now let's go ahead and combine the like terms. So you might be asking yourself, what are like terms? Well, things that look similar. For example, those 2 and those 2 are going to be my like terms. So let's start with the x's. So 3x plus 3x is going to be 6x. And then we're going to have negative 6 plus 6, which is 0. So plus 0. Then on the bottom, we're going to have the same thing that we had before. It's going to be just 24x. Now, 0 is not going to affect my problem, so I just got to go ahead and rewrite it. So I have 6x over 24. And just like we did on the previous one, we need to simplify the fractions. Now, if you don't know how to do this, this is the easiest way to do it. Find the prime numbers of your numbers. So for 6, what gives me 6? 2 and 3. And then we have x right on the top. And then on the bottom, we have, this breaks down to 2 and 12. And then 2 and 6, and then this one breaks down into 2 and 3. Okay, we only care about the prime, so I don't care about those. So I would have a 2 times 2 times 2 times 3, and then the x. Okay, so now you would go back and you would delete anything that you have there. So this is the easiest way to go ahead and simplify fractions. So I know those 2 are going to cancel out with those 2, and that one cancels out with this one. Now, what's going to be left? On the top, nothing's left, so I'm always going to put a 1 if that happens. So it's going to be a 1. What the heck? There we go. 1. And on the bottom, you have, let me go back, 2 times 2. Alright, if I have 2 times 2, then, oh wait, my answer is 4. So the answer for the very first one right here is going to be 1/4. And now let me do a different one. Let me do one of the bottom ones, just so I can show you that it's the same concept, even if we have an expression on the bottom. Now let's do this one right here. Just like I mentioned before, you got to look at your denominator. If it's the same, then we're just going to go ahead and rewrite my problem. Okay, so I just rewrite it. I put the top 2x plus 3 minus, and I'm going to put in parentheses because look, we have a minus now. And what this is going to do is going to distribute and change the signs of those two. All right, we're going to go ahead and change that one in a bit. But on the bottom, it's just going to be x plus 4. We're going to keep the same denominator. Now, let's go ahead and simplify it a little bit, right? So because of this part right here, we're going to have to change those guys. So let's do this. So it's going to be 2x plus 3 minus x plus 7, and everything's over x plus 4. Again, I'm going to go back and combine like terms. I know that one combines with this, and this is going to combine with that. Let's start with our x's. So over here, 2x minus 1x is x. Three plus 7 is 10. Oh. On the bottom, we have the same thing. X plus 4. Now, can I do anything with those two? No. And we're done with there. And that is it. That is my entire problem right here. Okay, you're going to be doing the same thing for the other ones. So just go ahead and work on the other 4 on that one. Now let's go to a different type of problem. Now over here, the denominator is not going to be the same, so we're going to have to multiply one or both of the sides to get the same denominator. Now, you'll see how it works right now in a bit. Now, I can see both of my denominators. And here is, you just have to be very careful and very observant of what you have. So first things first, I got to see what one side has and what one side doesn't have. So let's look at this a little closer. So we have x, right? Now, the other side also has an x, so I know this side, well, let's focus on this side. I know that side has a 5 and x squared. Now, in my head, I'm trying to think, well, because I need to have the same denominator, and this side has the most stuff on there, how can I make this guy, the x, into 5x or 5x squared? How can I make x into 5x squared? So we're going to have to go back and multiply things to x in order to make it that. So in this case, we're going to do this. We're going to go ahead and we're going to have to multiply. Now, whatever you do to the bottom, you got to do to the top. So you got to be careful with that. So let's take that out. Oh my god, this is annoying me. I'm gonna delete it if I can. Oh my god. This is annoying me. Okay. Here we go. Let me see if I don't touch it this time. Alright, so this is what we're gonna do. We're gonna rewrite a problem, obviously. We're going to put 6 here, x here, and then plus 7 over 5x squared. Now, in order to make x into 5x squared, I know I need to multiply by a number, which is going to be 5. So it's going to be 5. And also, I need to multiply by x. Now, if I multiply that with that one, that's going to give me exactly what I want. Now, because we're trying to fix the denominator, we also have to apply the same thing that we're applying to the denominator, we have to apply it to the top, the numerator. So the same thing is going to be 5x up here. And now we multiply, and you're going to see what's going to happen here. Now, if you multiply, this is what's going to happen. This is multiplied with this, and this is multiplied with this. So we're going to have 30x on the top over 5x squared, which is exactly what we want. We want to have the same denominators. Now we have 7 over here and 5x squared. Now, as we have the same denominator, we can now convert this into one fraction. So we're going to go ahead, combine that, and we're going to keep only the denominator. We don't have to add the denominators. We just keep the same one. And on the top, we're going to have 30x plus 7. Now, we're going to have to look at the problem. Can I do anything with the 30 and the 5? Yes, I can divide by 5. But I also have a 7, so no, I cannot divide by 5 anything. So guess what? This one cannot be simplified, so we just leave it like this. And that is it. That's exactly what you're going to have, how you're going to have to do this ones. You're going to have to look, I'm going to do this one right here. Look at what you're missing on one side and trying to equal it on the other. So just like we did before, I know this x is going to have to change, right? Because we cannot have that. We need to have at least this guy right here, 6x squared. So what we're going to do is we're just going to try and figure out what we need to multiply over here. Now, pretty easy. I know I'm going to have to multiply by 6 because I need to have a 6 on the bottom and also an x, just like we did in the previous one. Same thing, 6x. And now we go ahead and multiply them together like this and this x and that. So that's going to give me 24x over 6x squared. Now on the other side we have plus 7 over 6x squared. Now we simplify, we turn it all into one fraction. So this one's going to turn into 24x plus 7 over 6x squared. And guess what? We can't simplify that one either because of that 7. That 7 is not letting us like simplify anything. Because 24 and 7 don't have a common factor. And that is it. That's how you're going to be working this ones out. So they're not too hard. Now, as we move forward, you're going to notice that they're going to start getting harder. Now, I didn't put any steps on this one because it's just a lot. Whenever you actually come to this type of problem now, you're going to notice that we have a whole, we may have the same thing. So this one is equal to this. So that's pretty easy. But before we go ahead and do all the craziness of converting to one fraction, what I want you guys to do is simplify whatever's on the bottom. So if you have a trinomial, which is this is a trinomial, and this is also a trinomial, you're going to have to go ahead and simplify first. Once you simplify, you're going to be able to go ahead and do what you need to do, which is multiply maybe one of the sides by this, or trying to equal it out, and you'll see one of the problems later on that we're going to have to actually do that. But for this one, we're going to have to go ahead and do the x. Now, we've been doing the x method for like about 3 weeks, so this should be pretty easy. On the top, you're going to do a times c, which if you remember, that's a, b, and c. And let me change the colors on those two that I put right here. So a is this one, and c is this one. There we go. And then we're going to have b on the bottom. Okay, that's how you always start this type of problem, which should be relatively easy. So in this case, it's going to be 1 times negative 7. It's going to give me negative 7. On the bottom, it's just going to be negative. I hate when I do that. Negative 6. Now we need to do a t-chart of negative 7. We need to find two numbers that give me 7, which is 1 and 7. And guess what? That's going to be it, but the negative has to be the bigger one. So it's going to be 1 and negative 7. Now, if you remember, how do we write our factors? We always put x, and then we write my sign and my number. X, my sign, and my number. There we go. And I was referring to the two numbers that we just wrote right there. All right, that's factoring. We already factor it. Now let's go ahead and simplify this a little bit. Now what we have on the bottom is going to be this. So I'm going to rewrite almost the same thing. 5x minus 4 plus, and then 5 minus 4x. Then we have this, this. We're going to go ahead and write the new factors that we have for this. So x plus 1, x minus 7. Same thing over here, x plus 1, and x minus 7. Like we mentioned before, we have the same denominator, so we're going to go ahead and turn this into one big fraction. So it's going to be 5x minus 4 plus 5 minus 4x. On the bottom, still the same thing, x plus 1, x minus 7. We're going to go ahead and find my like terms, because we're going to have to combine them. So what do we get? So 5x minus 4x is x. And then negative 4 plus 5 is positive 1. There we go. That's what I'm going to get on the top. And now let's just rewrite the bottom one. So whenever it comes to this type of problems, you're going to notice some of the time, not always, but some of the time, things are going to be able to cancel out. So now we have everything that we need, and what do you think is going to cancel out? The x plus 1s. So knowing that, my answer is going to turn into 1 over x minus 7. Boom, and we're done. All right, let's do another one just so I can show you the same concept. Right here, this one right here is the same thing. So let's do the x method. Let's figure out what's going to go on the bottom, and then we'll rewrite it. So I know my a is 1, my b is this one, and my c is 4. So let's start with a times c and b on the bottom. Okay. So 1 times 4, 4. Now we need negative 5 on the bottom. Well, it gives me 4. 1 and 4, and guess what? That's going to be my answer, but both of them are going to have to be negative to get that negative 5. Negative 1, negative 4. Now we're done. Now we can rewrite the entire problem. So I'm already going to go pretty quick here. It's going to be 3x on the top minus 4 plus 3 minus 2x. On the bottom, I'm just going to put my two factors, which is going to be x, and then the sign, and then the number. Then x, the sign, and then the number. Boom. Easy. We combine like terms, which I look at this guy. It's going to combine with this. And then this guy is going to combine with that one. So we have everything that we need. We're going to combine the 3x and the 2x, which if you do the math, it's just going to give you x again. If we do negative 4 plus the 3, we get a negative 1. And I'm going to put in parentheses. I don't have to, but just want to make sure. Okay, that's what we have on the top. And now on the bottom, this is what we have. X minus 4. And guess what's going to cancel out? X minus 1s. Which is going to give us 1 over x minus 4. That is it. That's my answer for that problem right there. Pretty easy, right? You're going to have to do the same thing. You're going to have to simplify it. Okay? Not too difficult. Now, with this one, it's the same thing. But guess what? We have two trinomials now. Meaning that you're going to have to simplify them both. And then we figure out what we need to multiply on one side or the other. All right, so let's do that real quick. Okay, let's do the first one. So it's going to be my x. I know I have a 1 in there, so it's going to be same thing. A, B, C, A times C, and then B on the bottom. 1 times negative 4 is negative 4. B is 4. Now, how am I going to be able to get negative 4 and 4? Is it even factorable? Let's figure it out. Actually, it may not be factorable. Give me a second. Okay, so let's just do our two factors here. So 1 and 4 and 2 and 2. Now, this one's not going to be factorable for the next reasons. Okay, I need to have a negative 4, right? If I multiply. Now, that's understandable. I can make one of them negative, right? That would give me that negative 4 here. But if I go ahead and add them, there's no way I can get that positive 4. So this is not a factorable one. So the top one is not factorable. I think that's how you spell it, factorable. Okay. Now let's go ahead and try the bottom one. Okay, so the bottom one, same thing. We have 1, we have 4, so I'm going to label them A, B, and C. And we do the same thing. We're going to go ahead and multiply. So 1 times negative 12 is negative 12. 4 on the bottom. And let's do our little chart here. So 12 is going to be 1 and 12. 2 and 6. And then, there we go. I think I figured it out. And 3 and 4. Now, in this one, I'm going to pick the 2 and 6, but the 6 has to be the positive one, so that one's negative. That's going to work because that's going to give me a positive 4 if I add them, but negative 12 if I multiply, which those are my two factors. Let's go ahead and rewrite my problem. So instead of having, we're going to have x minus 1. And then this one's going to be minus still. And it's the same thing because we couldn't factor it. Then on the bottom, we're going to have what we called, this one's still the same thing, x minus 2, because we didn't change that one. Now we're going to write our two factors, which is going to be x minus 2 and x plus 6. Now, we have two fractions, and we're going to be applying the same rule that we applied before. Now, what is this fraction missing on the denominator that the other one has? Well, you're probably thinking already, and you're like, that's obvious. We're missing the x plus 6. And guess what? That's why we're going to multiply the top and the bottom by x plus 6. Okay, now we have everything that we need. So now we combine it all together. And this is literally the hardest part whenever it comes to this type of problems. Now let's combine them. So we're going to have x plus, let me close that parentheses, 6, and then we have x minus 1, and then we have x minus 4x minus 4. Okay, now we're going to have to do something with this in a bit, which is, this is why this type of problems are a little long. Now on the bottom, we're going to end up with x plus 6 and x minus 2. We're still not done. Now, in order for me to be able to combine like terms here, and I'm going to put this in parentheses because we have a minus, this minus right here, because that's going to change the sign, so everything in later, I'm going to have to distribute the x plus 6 over here and x minus 1 so I can combine like terms. So let's do that. Oh my god, this is a big problem. So I'm going to go up again. So I'm going to go all the way up here. And then I'm going to finish it. So let's go ahead and multiply it. So how do we multiply this stuff? It's pretty easy. There's a FOIL method. We do x times x, which is x squared. We do x times negative 1, which is negative 1x. Now we do 6. 6 times x is plus 6x. And now 6 times negative 1 is negative 6. We combine like terms, so I'm going to end up with x, 2x, right? Or x squared, I don't know what I'm talking about. Plus 5x minus 6, and now we write the other stuff that we had, which is going to be x squared minus x squared, because we're going to have to change the signs, right? And that was a positive 4, so now that one turns into negative 4x plus 4. Now we can combine like terms. I know this is going to be one of those problems that is just going to make you brain hurt. Okay, I'm trying to combine like terms. I know that one's combined with that, and we just combine. So finally, that we have all of this, we're going to combine everything together. And if I know what's going to happen next, the next stuff that we get is probably going to be factorable, so we're going to have to factor it and then cancel out stuff at the end. So this is a super, super long problem. So x minus x is 0. Oh, actually, it's going to work really nice for us. So those two cancel out, right? Now we have 5x minus 4 is just x, so we're going to have, let me delete that, 0. It's just going to be x. And then finally, at the very end, that cancels out with this, plus 2. Okay. No, I'm wrong. It's negative 2, because the 6 is bigger. You see, you got to be careful with your signs. There we go, that cancels out with this and this, and now we have all of this. We have x minus 2. And if you remember the denominator, x plus 6, x minus 2. So x plus 6, x minus 2. Okay. And now, finally, we cancel out the x minus 2, so we're going to end up with 1 over x plus 6. Sorry about that. I didn't have enough space for that. So whenever you're working on this type of problems, make sure either work it on its separate sheet of paper. Most likely, I'm just going to put it in Google Classroom, and that's how you're going to be working those. Now, this type of problems, same thing we're going to be doing in simplifying the bottom part. Break it down, and then go ahead and see what you need to multiply, just to make sure you you get the same denominator on the bottom. Literally, that's the whole point. It's not very hard. It is tedious, obviously, but it's not too hard. All of the skills that you need, they're already there. So that's all I'm going to have to say. And that's it. That's the entire problem. Right? I think that's pretty much sums everything up. Make sure you work on all of it. Try and finish as much as you can. And yeah, that's pretty much it. Well, I'll see you guys later.